So the opening question that I have is very direct, really. What does the idea or the concept of minimum sustainable data set mean to you? Who would like to start? Sergio, would you?
Yes, I can start. Thank you. So, first of all, thank you for inviting me and also invite me to think about minimum sustainable data set. It is a concept that unfortunately is not that spread. You don't think and hear about that much. We quite hear the opposite. So collect as much data as you can, process as much data as you can. Um, in in the EU AI Act, there is this definition of general purpose AI system with systemic risk. And system with systemic risk are those that are trained with at least 10 to 25 floating operation points. And so that means a huge data set, billions and billions of parameters. But what about making it small? So for me, minimum data sets are privacy preserving, are avoiding redundancy, and are actually good for most of the AI tasks. So sure, I don't think you can replicate the next GPT-5 with minimum data sets, but what are the tasks that we are actually doing with AI? And if we think beyond LLMs, if we think about all other kinds of application that can support us in our everyday life, we don't need this kind of redundancy. We actually need to stay focused. And as I mentioned before, we could avoid overfitting by avoiding redundant data sets. And we could avoid privacy breaches and incidents because we ultimately do not know what happened with our personal data that are processed. We don't know what kind of personal data of us is processed. And knowing that a principle of minimization of data collection and processing is adopted, of course, can reassure us against this kind of privacy incidents where as personal data maybe in an unwanted way then are given out as an output or are vulnerable targets of cyber attacks and so on. So I see the principle of minimizing a data set size and having minimum datasets as a very intelligent principle that should guide the composition of datasets for AI application in the future.
So I have to say, I was agonizing about this question a little bit because I cannot really picture anything under the term of minimal sustainable data set. So is it a metric? Is it a scale that we're talking about? Like my first thought about like, what does it mean? Is it like 5? Is it 20? Is it 200,000? So it's a little bit weird. But I thought maybe we can approach it from like a very pragmatic and practical point of view. And so my background is like I do data-driven investigations. I used to do them like in the human rights context first. Now I'm having the privilege to do this like in a journalistic context. And when we do human rights investigation with data, what we try to extract out of the data is the proof or facts about human rights violations, proof of genocide, proof of like that something happened or a story of a survivor. When we do the same thing in journalism, what we try is to extract a story, a narrative, a thing of like, why does it matter? Why should the reader be interested in this story? Like, why would they give us like their time, the 10 minutes a day when they're reading news? And so when we work with data, we have like, we get data sets that are like very small, sometimes just like 100 rows in an Excel sheet and it's super simple. Sometimes they're like 500,000 PDF documents, it's very complicated. Sometimes it's like some other form of structured data and very often it's messy. And what we are doing normally is like this data set itself is not the story. This data set itself is not the human rights violation, but it contains it. depending on the question that we are asking. And so what we're doing normally is like we try to reduce the data set. We try to ask a question, and through a process of verification, we try to get to like some fact about it, some proof of like that we can make a statement about it. Sometimes we can work for weeks on one data set. We extract two, let's say I have 1 million Telegram messages. Is 1 million like small? Is it big? We don't know. But like I need to extract 2 Telegram messages because then I can put like one line into the article. This is like a typical workflow that we have. So asking, if I have to ask myself what is minimal, it's basically like how much can you reduce it? How much can you focus within the data set in order to get like the answer that you're looking for? And so how I think of data is like that when I get it, it's basically just information. And it's only like through verification, through asking a very specific question to the information, you actually extract the data, you get the data set. This also means that if I ask a different question with the same information, I will get a different data set. So this is kind of like my thinking. I don't know if it fits the topic, but this is how I think about it. It's a process-oriented thing.
Nice thoughts. I don't know. I was also like really. It is kind of like mind-bending idea in a way to fit, because like if you think from the position of like I don't know privacy and all of those like things that we're like discussing in 5, 6, 10 years ago, then minimum data set have a lot of sense. But if you think from the position of AI training process, I will maybe start from completely opposite idea and try to question maximum size data set first. Like first to think like what will be the maximum size data set, and so basically even if we have, I don't know, for example, all the books in the world ever written, all the text ever, you know, like exchange on chat or whatever, all together as a data set, that data set will also not be good one, not be perfect one, because it will be representation of historical bias. It will represent who in history had computer, who didn't, who had a printing machine, who didn't, who had an archive, who didn't. So anyway, even if it's the biggest data set ever, it will be representation of power. So, and then I will try maybe to dissect from there. So the maximum one is not good one. What it means shrinking the one into smaller one, it's again question who is going to shrink it? Like who will curate shrinking of the data set from everything that was ever written, no? So I remember when we were like 10 years ago or whatever, like had this idea about like, okay, we want to archive internet. What will be the most efficient, like in this idea of like dark age and digital dark age, what will be the best medium to do it? And then Bruce Sterling said like clay tablets. That's the, you know, clear, you know, medium, because like we have like proof that it's 5,000 year functional. But then the question of, okay, it's not just about it, it is about like how cheap the medium is. And then, so more expensive medium it is, more you're shrinking the data set, you need to make more decisions, no? You need to curate shrinking of the data set. And then that means that the curator is the one who is going to have a power to choose what will be in the data set. So if we think about the data set as a source of statistical space that it will be created from this data set, minimum data set means less options that are created by someone, no? Chosen by someone. But then in that sense, it's counterintuitive to think that smaller is better. But it's also a question of strategy. What do you want? Do you want to be represented in a data set? You can say, okay, all of those things, like, I don't know, from the question of like any kind of, you know, like the groups that are usually not represented, do you want to participate in that game? Because if I don't know, if we are speaking about like OpenAI or whoever, do we want to make their data set better or not? So do we want to push to participate in that game and say, okay, your data set is not good and let's make more diversity and whatever and make a better data set to make your fantastic private tool to run our life, no? So I think it's also a question of strategy, like, do we want also to participate or not? I think if we deconstruct this, how the AI is being trained, smaller data set means more entropy, no? More chaos, more different things. Bigger the data set, it is like, but it also creates a lot of problem for us. We had like this project, participated together in some kind of research group specifically about data set. And now data sets, and now we are in a situation what you are doing when you have 1.6 billion images somewhere, and how the scale of data sets that are being used are now too big for us to examine, to find a way how to do, even to what kind of questions we are going to ask the data set. But I'm not so sure that the in that sense, as a strategy, insisting on a smaller is one-to-one like better. It's also a question for what, and this is maybe the problem in this sentence, is like that we don't have like, I think second part of the sentence is missing. Okay, you can create a super small data set for your, I don't know, noise, poetry, minimal music that consists only of one thing, and it's going to be interesting. But yeah, so okay.
1, 2. Okay, so I'll talk a bit from a different perspective. We started with this idea when we talk about data sets, we use them for generation of model, which will generate the content or something. Yeah. But in my world, and I'm a law professor teaching engineers and managers to use data, principle of minimization is like the main thing I want to teach them. And at the moment, I have like, I don't know, 4 or 5 master theses with the main topic of how to use principle of minimization, development of HR practices, of a system of monitoring of something, blah blah blah, and so on. Because I'm data protection lawyer by nature, and why is that the perspective? Because on one side, our business and organizational culture, as we all know, is based on some premises, and these premises are very simple: more data, better result, collect them all, and then you will get somewhere. And also, if you talk about scientific method, it's very similar, regardless of the fact that we're talking about the scientific research or just regular investigation. In order to be conclusive with your argument, with your conclusions, you need volume, you need representation on a large scale. But in practice, we have this culture in organizations, both private sector, public sector, academic sector, and so on. But we tend to teach students, at least that's my role, that principle of minimization coming out of GDPR and data protection regulation is to use as little data as possible to achieve the goal. And that's really imperative imposed by regulation. So just to provide a very simple example, like you're developing something and you need age, because age is requirement to provide the service, because maybe it's born, maybe something else, doesn't really matter. But then you don't need date of birth. You just need, is it over or below 18 or any other age requirement. And then implementing in design of data sets these principles is really important. But as I said, it's different environment. It's not the environment of training. Why? Because it's very specific purpose, and it's easy to apply principle of minimization to specific purpose, because then it's possible to play that game. When we talk about AI today, we talk mainly about general purpose AI and general purpose AI for generative purpose. So it's like we want to again catch all the potential uses and so on. And then we come to the question, as said, we are developing the model, and we need more to be able to generate better, regardless of the values we want to impose on the model. It's possible to do to minimize the data set, but that really means putting a lot of resources in adjusting the data set, putting a lot of resources in data preparation. We want to work on data structures, we want to work on quality from a perspective of truthness and verification of data and so on. So we can get the minimal data set, but then we have a lot of labor in order to get it. So we still have huge impact. And what we all know from our work, it's very nice to use unstructured data, because then you can see, can you get something out of it or not? You don't need to put so much energy into data preparation to be able to assess the potential of that data set. So maybe to stop here, then continue.
I was wondering among the people on the panel if there's anything that's emerged from what you've heard that you'd like to follow up on.
Yeah, if I might jump in, I heard a concern about an efficiency concern about minimum sustainable data sets. So I wanted to clarify something also from my perspective. First, how small or how big should these data sets be? Maybe minimum sustainable data sets in some fields are not that small. Let's take as an example what we did in the last year with LLMs. So surely also in your working environment, suddenly everybody started experimenting with LLMs and trying out different models trained based on a different amount of parameters and data. So I recall when the first LLM services and platforms emerged, powered by different providers. I once tried out the demo platform by IBM, and also other providers started launching this platform, aggregating different kind of LLMs, and then everybody had a choice between different models, and it was very interesting to see that the biggest model were usually underperforming in certain tasks. So actually, according to the task, there is a minimum viable data set and also a maximum viable data set. So for example, those huge models based on 70 billions of parameters, you couldn't use it for basic tasks. It was a waste of computational resources and of time, because you had to do the task again yourself or redo it with another model. So it's also an optimization question. There is actually a needle size, how the model, what the ideal model size should be for a certain task, and this is variable. It really depends on the task, and sometimes it can out that the smaller one is faster, is better, is more resource efficient, and this is a big deal because many companies started experimenting this year with these services, and then at the end of the month, this huge bill arrived by OpenAI or by other providers, because it's actually not that cheap at the thought. And using the smaller model also means saving more money for the same output, basically. So this is also a thing that I wanted to put on the table.
Yep. So it's a thought that also, like, I'm listening to what everybody has said. Like, I think that maybe, like, we can think that minimum, it's not less data but more compressed, and then that's a topic and can relate to the sustainability concept that we are talking about. And then in that with that idea in mind, I think the issue of who decompress, who can read, or like, then this is the issue that maybe we can think about, like, what's the workaround if we solve with a new way of, like, the data sets are more compressed, and then in that sense are more sustainable for storage. Then the issue of dark data, right, like data that it's missing because nobody can access it anymore because it has been, there is no key or something like that, right? So we just wanted to talk about, because minimum doesn't need to be per se less, but it could be something else.
Maybe I can add to this. So I think that's a very good thought. When we do human rights investigation, like the point is not to, for example, verify all the data. Like this is not a category we are working on. We are verifying enough data so that we can make a statement about it. We can make a statement of truth, a statement of fact. For example, with 1,000 YouTube videos depicting like one attack on a hospital, we have to verify 10 in order to be able to prove that this attack happened. Maybe we can prove who did it, for example, right? And the other 990 we can ignore, for example. So I think it's often about like we just have to create data sets that are enough in order to for whatever purpose we want to use them. So if we create like publish a story in a newspaper, like it's a different type of verification, it's a different type of like rigidity that we have to apply. When we produce a data set that should be used in front of court because we want to prosecute war criminals, that's again a very, very different story of like how we have to deal with the data and how much of the data we have to go through. But there's also the other example that I can bring. So that's an investigation we did into the ongoing war in Gaza. And like one problem we're facing was like it's very unclear what is happening when at what time, right? And so you can look on social media, you can look on media reports, but they're very, very like you cannot trust them. You can't read a Telegram message and say like, oh yeah, it depicts like a tank attack at this corner in this part of the city, so therefore this happened. So this is like absolutely like you cannot build any kind of statement on top of this. So here, what we did, like the approach that I took was like, okay, let's go through a lot of data. So I scraped 1 million Telegram messages. If I found like for one particular time, one day, like 20 of those messages, it increased the likelihood that maybe these 20 messages were true. But again, like none of them were true because it's Telegram. You can't believe anything you can read. But also, it's just you work in likelihood. And so very often doing this kind of data work, you're just trying to get to a point of like that you can increase your probabilities. Like you cannot put a number to it. At least I don't. But it's more like a thing of like I feel like this is more likely that it happens, for example. And I think like what you also said, like we should separate data sets like that are used for training and data sets that we actually work with. These training data sets are crap. Like I don't know. Like I mean, I'm gonna talk about it tomorrow, but like I don't want to take away my talk from tomorrow. But like, but I can really recommend you to listen to it. But I think most of the data sets that exist, most of the data sets that we actually encountered, most data sets that are relevant for us are not training data sets. They might be like in scale the largest one. Maybe they're like really like by a massive amount larger than the data sets that we are working with. But actually, they're not the relevant data sets. Like these large scale 5.8 billion image text pairs, these are not data sets that we really work with. Like we don't do anything with them. Like, they're not made for us. Like they don't give us anything. But like then I get like a data set that is like 18,000 images of birds, and that's something I can do with. That's I can have it on my laptop. I can look on it in Finder. Like it's not a problem. Like so, I think like most data sets actually that are relevant for us are not having this scale. Like they're not affected by this problem nearly as much.
because those are completely two different, and I think it's important to understand this difference between like it's a different way of doing things. Like what you describe is looking into. So you have a data and you look into data as a human being, or even as a whatever tool you're using. You're looking into in order to find something, in order to make some kind of conclusion. But generative AI is not looking into; it's projecting from data, and that's a different, completely different paradigm. Paradigm. Different paradigm. So it is completely different thing. So you project, you take everything, you compress into some model, then you project this as a rule, as a reality. And this is like why it may be important to understand and make a difference between, you know, like data that is being used for scientific research or like investigations, and data that is being used to create synthetic models that will be used to automatize different things in our life. Because that data, you know, you when you are investigating data, you're searching for anomalies, no? Trying to answer questions, trying to find something specific. When you compress data into the model, basically it's not about it's a completely different process. It's not about anomalies anymore. It is about statistical space. It is about probability. It is about more. So you are basically projecting some kind of average image of reality that you found in data sets. So it's completely different drawing.
And then just to go to the regulatory side again. So I talked about data protection and privacy principles. But when you go into AI Act, the principles are completely different. So we are talking about data governance in AI Act, and we talk about the data set. And there are like 6 requirements of the data set in AI Act. First is relevance of data. What we can say it's minimization on one side, control, not all the data. Adaptation to the sector and purpose. It's again, reduce what's relevant for sector and purpose. But then representativeness, you have to go wide. Impartiality, you have to go wide. Accuracy, that's again quality, that's go control, but completeness, the 6th one. So again, go wide. So 3 of them go in reduction, and 3 of them ask, go and grab everything in the field. Yeah. So they are not completely in conflict, but in a way, 3 of these principles are requiring to catch everything complete.
Well, there's a lot in that.
Yeah, I just wanted to mention something, to draw a little bit on what Sergio mentioned and what you're doing. So, and what we are all here because of, right? That's civic activism and citizen science. So yes, the large models, the larger it is, the more computing power it needs. The larger the data set, the more computing power you need. And when we were discussing about minimum data set, we were thinking about all those people who would like to do citizen science, who would like to use Climeco, and who would like to enrich these data sets that they get from Climeco with the free data that they could draw from Copernicus, right? Satellite data on the weather and everything, right? And that's one of the that's where while we were discussing about the minimum data set, that's what we had in mind. So what would be the minimum data set that would need some average everyday life computing power to process and to use for your own purposes, right? And I believe, well, yeah, well, I don't have any solution, but I wanted to steer the discussion maybe into this
Do you
direction.
have maybe a question that would?
Yeah, that was a comment that was like a little sting to steer the discussion in this in this field where we are all from civic activism.
Maybe if I could help make the question shorter, it's like how could citizens that do citizen science somehow use these huge data sets in their home with their home equipment? So it's a real example of what kind of storage you need, because Copernicus data set is huge, but you want to question all of them. Does anyone want to respond to that, Sergio?
Yes, of course. I mean, it's not a kind of endeavor that normal citizens alone could strive. So this is actually a political question. So how do you make datasets for the common good? And I met Desiree at the Global Solution Summit. It's powered by the Global Solution Initiative. They were writing very interesting white papers about data commons. And this is something that we have just in very limited application fields like research. And the idea is that we will need data commons in way more fields of application, and these data commons then will be at the service of the citizens, that there will be a public good that people could use for the application. You cannot expect from everybody to be able to use data common, but there will be available public data that could be used for public good. This is a collective endeavor, and we do not have it. We should have it for many application fields, and I think that's something that needs political support and needs collective aggregation by the citizens.
Much. Are there any other questions? Any more comments from the floor? From the
Maybe I can add to what Sergio was saying just now. Like, I think availability is very, very important, and I would add to it, like, what is also important is transparency into the data set itself. Like, it's not just that we need to be able to get the data, whatever technical means. Like, it can be nearly impossible, like Copernicus, or it can be something much simpler. But to know and to understand what is in the data set and why it's in the data set, like what was the process of curating the data set, I think that's actually the interesting question here. Like this, because this decides, again, like I would put out a hot take now, and I would say like that bias in data is not related to the size of the data set. It has no connection to it. So where the bias is coming from is in the process of curation of the data. This is where the bias goes in, and then the bias of asking the questions and how you ask the question. But the data set itself, like the size of it, if it's like 10 rows of data or 8 billion rows of data, like it will not make a difference in terms of bias. So I think like transparency is like the one important thing we also have to add into this list of availability.
Yeah, I think the issue of disinformation that came up earlier, and the potential for it to just grow and grow. I was reading recently a Google paper that said that, really improving prompts and learning using something called chains of thought, which can link back to things, but it only works with large-scale data sets at the moment. So that leads to the question of, do you need to go big in order to ultimately improve the data responses from the learning models, which I think is a really challenging philosophical paradigm, practical one at the moment for all of us to grapple with. In a way, talking about the size of the data set is talking about it's only one issue, because what this goes back to is efficiency of the system and actually, doing stuff. It's not just the data set, it's actual, operation.
No, yeah. But I think we are entering into some kind of trap of again this kind of techno statistical solutionism. So like this idea that there is a proper data set, there is a proper machine that will do something. There is, I mean, I think sometimes we should like ask, do we really need that machine? Especially generalized machines, like big ones, like the general AI that will be applied to the whole humanity and everyone is going to use it. You know? That there is no chance that that one is going to fit all, because it will come from some kind of data set that they belong to some culture, to some company, some whoever, like whatever combination. Really small chance that that will go well. We are going into that direction, and this is like I think the core question of sustainability. It is like really going into this kind of like again, like this kind of like who owns the tools of production, you know, like whatever, if it's one tool owned by one company or 5 of them or whatever, it's not going to be good, and the size of the data set, it's not going to help, you know, with that. Maybe some kind of decentralization of I mean, we have to have like some kind of a lot of specialized tools that will be specialized in certain things, and they rely on certain data sets. But that's a probably better option, no? Than to have everything in 5 companies again. No? Then the problem now, we are not even like who have. This is also a question: do we really have a capacity now in this moment to compete with that? Like, who is going to do that? Who is going to pay for that? Who is going to pay this electricity? Who is going to, like, I think that the threshold, it's already really high. So, but core down in the before we start to question is any data set can be without bias or whatever, is a deep belief in a quantification and statistical understanding of reality. Because now we are building large-scale machines that are going to automatize statistical decision making and statistical vision, statistical thinking, or whatever. So I'm really for this kind of hardcore investigation of statistical logic at all, because like most of the statistical logic is based on a certain functions that, if you think about them in a political context, they are totalitarian functions. Bigger, better, populist, totalitarian, statistical future. It's what we are building. And it's not so sure the scale of the data set will solve that, but like maybe rethinking, that's not going to happen. Anyway.
For the conclusion, maybe just to reflect on 2 points. First one, the scale of data set. We can go minimal when we talk about number of data points. But then each data point has to be described really well, and the relations have to be put in a good order. So then we have another layer of data. So there is a balance between these two. So we, regardless of the number of data points, is it 1,000 or 500 photos in Bird's data set? If they're very well tagged, maybe 500 will work really good. Yeah. But then tags are also data, and like we have to calculate which kind of data are really minimal and not, and so on. But the other thing, when we go into AI, what Vladan said, but just to reflect on that, and with what I started, if we have a culture of tools for specific purposes, then this idea works. If we have a culture with a general purpose, catch-all solutions, one tool everyone can use for everything, then it cannot work. So that's really a question of culture and how we distribute the market and how we create business models and so on and so on. So I think that's really for thinking, do generative general purpose AI in this phase of generative AI is something what we want to make as a rule in our society.
Yeah. Maybe I could reflect before you close as well. I think we open up a lot of good ways of how to think about this concept and what's useful and what's not. And, you know, just rethinking about all these questions that we have here. To me, it bears even higher questions like, is digitization or all this digital transformation that we are seeing really is going to put a society on this transformative path to sustainability or not? And what are the right things to happen? And certainly, Sergio mentioned one of those, like digital commons, where the internet users are going to be part of that conversation rather than 5 companies doing that. Then there's a question of open source license as well, whether these big 5 companies will outsource it or keep some coggles to themselves. So yeah, we open up a lot of questions, but we also manage, I think, to dissect some ones that are bugging us. Back to you.
Good. Well, as you've said, you were the one who set us this task, and you seem reasonably happy with where we've got to. So on that basis, let me thank all the panel, including Sergio, for wrestling with this. And also thank you all for listening.